Hello everyone, my name is Chi. I'm 9 years old. Today I will talk about my homework. There are seven applications potential risks to both under and over relations in this field. In the spring of 1979, a lab worker in Sevenoaks, USSR, removed a collagen air filter in the ventilation system and didn't replace it. His note to Superbeer was never transferred to the official black logbook. So when the next shift rolled in, workers simply start production as usual. Now, in the most lab, this would have been a mirror mistake. But this lab was a biological weapons facility, producing huge quantity of anthrax, which if inhaled can kill up to 90% of those it infects. This deadly anthrax power floated out into the sky for hours, causing the largest documented outbreak of inhalation anthrax on the record, and resulting in at least 64 deaths. What happened to the Savalok was a tragedy, and the Soviet bioweapons program was a violation of international law. But these days it's not just state abhorrences bioweapons programs that keep bureaucracy experts up at night. Nor is an anthrax their largest concern. They're worried about an even more dangerous kind of black lab leak. Since 1970, researchers have been manipulating the DNA microprobe to give them abilities they didn't have before. This is called gain of function work, and it includes a huge body of specific research. The majority of this work helps humanity with very little risk. For example, the engineers viruses are uses of in vaccine production, gene therapy, and cancer treatments. But within a game of fashion relay lies an actually debate subfield where scientists engineer superbugs. Avocado knows an estimated portional kinetic cathinols and allocation. These EBBBs are typically variations of well-known viruses, such as Ebola or avian influenza, that have been engineered to be safe. More transformations or more deadly. These gates of this kind of work are much higher. If even more unusually dangerous virus escape a lab, it could cause a global pandemic. Viruses developing EBBB origins, this research could help us prepare for future pandemics, following us to jumpstart treatments and potentially save lives. For example, in early 2010s, several research teams created a deadly strain of bird flu with the novel ability to spread through the air between mammals. I've called this of the project a group that by creating this EBBB, we could learn crucial information about a worst case scenario virus under controlled conditions. But many cities agree that it's unclear whether bird flu would ever evolve in the wild as it did in the lab. Conversely, they believe the knowledge gained by studying this dangerous virus wasn't remotely worth the risk of creating it in the first place. Both sides of the original debate are trying to save lives. They just disagree on the best way to do it. However, everyone agrees that an EBBB lab leak could be catastrophic. Labs work in with dangerous patterns are designed with numerous safety features to protect the scientists who work there as well as the outside world, such as the ventilation system that decontaminates air. The artist spacesuit with dedicated oxygen. Sometimes buildings are even nested inside each other to prevent nature disasters from breaching the closed environments. But this technology is expensive to build and maintain. And even when our teach doesn't fail, there is still room for most common kind of mistake. Human error. Many human errors are incidental. A researcher spilled a sample, but quickly it disinfects the otherwise well-controlled environment. Other incidents, however, are much more concerning. In 2009, a researcher accidentally stuck themselves with Ebola contaminated needle, endangering their life and the life of those treating them. In 2014, six vials containing the virus that causes the smallpox were found in an unscarred hosted room where they have been forgetting for decades. That the same year, a CDC scientist annulling contaminated a sample of relatively harmless bird flu with a deadly lab-grown variant, and then shipped the contaminant sample to USDA. Well, these incidents did not lead to the large crisis. The potentially catastrophic consequences of an EBBB leak have one convinces many scientists that we should stop this kind of research altogether. But if that doesn't happen, what can we do to minimize risk? Well, first, we can work to reduce human error by examining past mistakes. Some experts have suggested creating an international database of leaks, near misses, and fixes taken that would help labs adapt their protocols to minimize human error and a robust, well-funded pandemic early warning system would help protect us from any disease outbreak, whether would come from a lab, leak, or a nature spillover. Developing the kind of global standard and databases necessary for these changes would be difficult, requiring unprecedented international collaborations and transparency. But we need to overcome these hurdles because pandemics don't care about border or politics. Goodbye everyone. Thank you for watching.